Hi, this is Tom, and this is going to be our last application of E, an exponential growth being modeled. And here's the problem. It says, United States GDP, or gross domestic product, has grown steadily at 2% per year since World War II. In 2013, the per person GDP was $53,000. GDP can be modeled by this equation here. A equals 53,000 times e raised to the 0.02 t. And we have two questions to answer here. The first one, what was GDP in 2013? And number two, what is the expected GDP in 2020? Well, here's what we do. So it says, what is the GDP in 2013? Well, notice that it's kind of given to us in the problem. Here in 2013, it was $53,000. Well, how would we get the 53,000 out? Well, what number one is really trying to show us is that 2013 is the base year. Is the base year for this model. In other words, it's time zero is what we'd call it. It is time zero, meaning the model works from this point in time forward. So if it's time zero, that means that if we let t equal 0, we would expect to get 53,000. Well, let's try that. So if I take a equals 53,000 times e to the 0.02 times t being 0, well, notice this is 53,000 times e. Well, 0 times 0.02, that's just 0. And any number raised to the 0 power is 1. So there it is, 53. This is 53,000. And e to the 0 is 1. And so there it is. So in other words, this model starts in the year 2013 and then models into the future time past 2013. So let's take a look. Using that model, problem 2 says, well, what is the expected GDP in 2020? Well, in 2020, 7 years will have passed. So in this case, time equals 7 years. So now we can use the problem with a equals 53,000 times e raised to the 0.02 times 7. Now to do this, to get a number here, we're going to need our calculator. So let's go over to our calculator. I'm going to go type 53,000, and I'm going to type in an e. Whoops, I should go back. Times e raised to the parentheses 0.02 times 7. Parenthesis equals, there we go, 60,964. We'll just put this in the nearest dollar. So $60,965. So we have $60,965. And actually, that'll be interesting. We're almost to the year 2020. It'll be interesting to see if, in fact, that really is pretty close to GDP in 2020. And those are the two. Now we've looked at the two primary applications of using the number e and how it helps us to study exponential growth. Thanks for watching.